Good morning, class. Good day, good evening, whatever time you're watching this. This is Mrs. Wormley, and I'm going to do a foldable today with you on how to find if triangles are congruent. So again, this is Mrs. Wormley for my Math 2 class, but if this helps you in other classes, then please, by all means, use it. So we're going to make a foldable, which if you've been in my class, you've made these before. So we're going to take a piece of white paper and hold it so it's longwise, so it's horizontally. We're going to fold it in half. And then we need 3 sections in our foldable that are going to open up, little flaps. So the best way to do this is to fold it over like you're going to make a burrito until your sides meet up, and then squish it down. It doesn't have to be perfect, but close enough. Doesn't really matter, but almost the same size. Open it up, and then we're going to open it up again. So now we have 6 sides, but we're going to make flaps because we're going to be doing all the writing here. So we're going to take each side and fold it into the middle, and then make another crease. Same thing on that side. Another crease. And now we're going to make flaps. So on these creases right here, we're going to cut. So now we've made our doors to open so that I can have I have 6 different flaps for 5 congruencies, and then we're going to do some symbols on here as well. So let's go ahead, and it helps me. So I'm going to open it up before I start doing anything. I'm going to take my pen, and I'm going to go down the middle of this crease just to give me some guidelines of where my writing is going to go. So there. And then there, and there. So now I have my borders inside. When I start writing, I don't flow into the other sections. So we can close it all up again. We're going to focus on one flap at a time. This video is going to be fairly long just because we have so much to write. So pause as you need to, and then pick up when you can. So our title is we're going to do on this side. We're going to first put your name. So I'm going to put Mrs. Wormley. And then if you're in my class, then please put your block. I'm going to put that right there so that if I find it, I can help you. Okay. So we're going to title this, How to Find If 2 Triangles Are Congruent. And so we have 5 different theorems that we use for this. So we have the side, side, side. We have side, angle, side. Angle, side, angle. These two get confused a lot. Then we have angle, angle, side. And then we have hypotenuse, leg. So these are our 5 that we're going to use. There is no ASS for angle, side, side, and there's no side, side, angle, because depending on the third side length, you can have equal angles, but then you can have different side lengths for that third side. So I'll show you more of that in class. So I'm going to open up this flap, and I'm going to just do a couple words for vocabulary for you. And actually up here, we can do this. We're going to put never, side, side, angle, or angle, angle, angle. Angle, angle, angle is because if you have 3 angles that are the same, so you have this, my angles are the same, you have the same angles, but then I can just make it bigger and bigger, so it doesn't matter. I don't know my size. So to be congruent, it has to be equal angles and equal size, equal shape. So I need to make sure that I have the same size and the same shape. So that's our first vocabulary, is what does it mean to be congruent. So when you see this symbol, that symbol means congruent. So this means congruent. And so that means that it's the same size, same shape. So that's what congruent means. And so we're going to use that symbol a lot because it's a lot faster to write that than it is to write the word out for congruent. And then the other symbol I want to write and kind of distinguish between the two is you have this symbol that looks like that. And this means, this little tilde, it means that it is similar. And so sometimes people ask me, well, how do I know if it's similar versus being congruent? Well, if it's congruent, it's the same size and the same shape, so it's the same size aspect. You can have similar triangles, and those would be the same shape, but they're different sizes. So same shape and different size, would that be that? Okay, so then the other thing I wanted to talk about in here was that if I have this symbol, or this triangle, let's draw a triangle first. We're going to be using triangles of all different types. Doesn't really matter what triangles you draw right now, just whatever one you want. I'm going to label this by its vertices, A, B, C. And so this is the triangle ABC, and so we're going to write this way, triangle A, B, C. So if I want to name this triangle, I'm going to name it like that. So a lot of times I'll give you figures and you have to tell me what's named or use the name to explain something about it. So this means triangle ABC. So at this point, make sure you have this done, and if you need more time, then go for it. You need 2 highlighters or 2 colors. I'm going to use my yellow and my orange for most of these. If you want other colors, doesn't matter, but you need 2 that we'll use continually throughout. So the first one we're going to do is the SSS, which is side, side, side. And so if I have a triangle like this, and inside, for all these triangles, we're going to be doing the same thing. The angles are going to be capitals. So here's angle A, triangles, and ABC, and then our sides are going to be across. It will be lowercase as the name of this side. So this is side A on this side and side C over here. And so in this one, I'm looking at the sides. So whenever I do sides, I'm going to be using orange today. So I'm looking at this side, and that side. So if I'm looking at my triangles, I'm going to be able to tell if they're congruent by looking at just the sides. The angles, if the sides are all the same when they meet together, then my angles will have to be the same as well. So I'm going to open this up. And in this flap, I'm going to put the name of it again. So this is the side, side, side. And I'm going to write the letters, or the words underneath it like that. So this is side, side, side. And because I'm talking about sides, I'm going to highlight that in orange. And so I'm going to draw 2 triangles. And in these are going to look, again, you want yours to be similar to mine. They're not going to be exact because we're just kind of estimating. And so this is going to have the sides. I'm going to put 1 line, 2 lines, and 3 lines. Those lines just mean that I know they're all different on this triangle. So this is going to be triangle A, B, C. And this length for the 1 hash mark is 5. This one is 4, and this one with the 3 hash marks is 7. And I'm going to take this, I'm going to draw a congruent triangle, and I'm going to create this by just taking this and then reflecting it. Like I'm going to pick it up and I'm going to turn it up over this way. So I'm going to reflect this. So now I'm going to go this way. So if I reflected this, then this side over here will be still 4. And the 2 hash marks here and the 2 hash marks here means that they're the same size. And then I'm going to have on this side over here will be length 5, matches with that. And this one is length 7. And this is A, B, C. So we're going to call this one D, E, F. And so we're going to use this side, side, side. I'm going to highlight the sides again, because that's what I'm looking at for this theorem. And so I can tell, because my sides are all the same, that these are congruent triangles. They're in different, like they're oriented differently because I actually reflected this one to create that one, but they have the same sides. So what I'm going to be able to say here is that triangle ABC is congruent to triangle DEF by SSS, by side, side, side. And so here's our definition, or our theorem for this. It says if 3 sides of one triangle are equal to the 3 sides of another triangle, the triangles are congruent. CONGRUENT. So we're looking just at the sides in this one. And the next one we're going to look at is side, angle, side. So I'm going to close these two up so I'm not distracted by them. So I have side, angle, side. And so I'm going to write the words out to remind us. The order of how the letters go are really important for this. So this is, I'm looking at a side, then an angle, then a side, and the order again matters. So I'm going to draw another triangle, and I have angle. I'm going to use ABC a lot for these. So A, this is angle C, that's B, across is A, that's B, and across over here is C. I'm looking at these now. So I'm looking at, my angles are going to be yellow. So this angle and then I'm looking at the sides that are on either side of it. So I'm looking at this side and I'm looking at that side. So when I look at this triangle, I'm looking at my side, my angle, and then my side again. So it's like they're connected together. Side, angle, side. So I'm going to open this flap up now. And again, just like I had the other one, I'm going to do some stuff up here. So I have side, angle, side, and I'm going to rewrite that going down just to get it in my brain. The more I write it, the more I see it, the more I remember it. And then I'm going to draw 2 triangles. This time I'm going to rotate them to show the second one. So here's this one, looks like that. And so I'm going to continue my alphabet going around. And so I had A, B, C, D, E, F, and now here I have G, and I'm going to go H, I. And on this triangle, I know that this length is 3 6/10. This angle is 49 degrees, and this length is 7 1/10. So I'm going to take this, now I'm going to rotate it. So I'm going to like pick it up and rotate it, turn it around, kind of spin it. And so it's going to look kind of like this one now. And so this one I have H, I, J. And so I'm going to move this down here. I have K, L, oops, J, K, L. Oops. So G, H, I, J, K, L. And so L is my angle, that's 49 degrees. And then this length here is 3 6/10, and this over here is 7 1/10. And so I'm going to again look at my sides, and I see I have a side here, that's 3 6/10. Angle's 49, and my other side is 7 1/10. And so this is just another orientation. This is 3 6/10. There's my angle of 49, and there's my length again of 7 1/10. And now is probably an important time to talk about that, remember, any drawings that you see are not drawn to scale. You can tell here that this is actually, looks longer than this one does, but that doesn't matter. I'm telling you the information, so you always look at the information that is written, not at what it looks like, what the shape looks like. So I have those two triangles, and so I got this by rotating. If you want to write that down, you can go back up here and write that these were found by doing a reflection. Come back down here. Okay, and so I'm going to use my geometry language, and I'm going to say that triangle, in this case, it's A, B, C, D, E, F, G, H, I, always after the alphabet, G, H, I, is congruent to triangle H, I, J, K, L, J, K, L, by, and in this case, it's side, angle, side. And so remember, so my side, my angle is between my two sides that are congruent. If you want to use little hash marks to help you see that, we can do that. So it's the angle that is between the two sides that are congruent. So in words, the way that this is defined, this theorem, is that if two sides and the included angle, again, I'm talking about the angle that's between those two sides. That's what included means. So I'll write that so you remember later. Between the two sides, like where those two sides come together, of one triangle are equal to the corresponding means like the matching ones, sides and angle of another triangle. The triangles are congruent. We have a lot of these if then. I should say then the. So if and then statements. So those are typically theorems. So if two sides and the included angle between the two sides of one triangle are equal to the corresponding sides and angle of another triangle, then the triangles are congruent. And if you look back at what we wrote up here, we said the same thing up here. It says if three sides of one triangle are equal to the three sides of another triangle, you should have put then the, so go back and fix that, then the triangles are congruent. So these are theorems, and if these things happen, then we know this is true. So I'm going to close that and then open here. Remember, you can always go back or pause if you need to. So now I am on this middle one on the right side, and we're halfway there. This is the angle, side, angle. So again, I'm going to write out the words. I just feel like going this direction this time. If you want to write out the words like I have here, then you can. That's up to you. So angle, side, angle. And so again, let's draw our triangle. Show you the parts we're looking at. We're going to stick to A, C, B again. Across the angles are the sides that correspond. And so this one I'm looking at an angle, the side between the angles, and then another angle. So I'm looking in this case, I'm going to stick to the one down here. Angle A, side C, and angle B. So the side has to be the side that's between the two angles in order for this to be true. and to work for us. So again, it's angle, side, angle. So I'll open this up, and again I'll write angle, side, angle, and I'm going to draw my triangle. This one is MNO, and on this one I know angle M is 23 degrees, angle N is 124 degrees, and this side is 8 9/10. And so I'm going to get this one, I'm going to rotate it again, just like I did the last one. I'm going to do a rotation, and we're going to spin it around so that it looks kind of like this. A little different orientation. And then this one is still my 124. Again, remember, may not be drawn to scale. This is my 23 degrees, and this length between those two is 8.9. And so this is PQR. And so this one, remember, all I did is I rotated it, so now this one's on the bottom. We have this, and then this angle is now over here. So this has been rotated. Could also possibly be found by doing a reflection, possibly. So in my mind, I just did some rotation, but we can put /reflected. Looks like maybe reflection might be more accurate in this case. So it's always nice, you can put paper over and trace it to see. So we'll put rotated, reflected. Maybe you want to find out which one makes more sense in your brain. And so now I'm going to, down here, put in my geometry words that because I have angle, side, angle, let's highlight angle, and then this side, angle, and then again over here I have between the 124 and the 23 degree angles, I have that 8.9. So I have the two angles with this in between. That's how I know this is angle, side, angle. And so we can say triangle MNO is congruent to triangle PQR by angle, side, angle. So we're going to be using these in our proofs. So I want to make sure you know kind of what that sentence would look like, how you would use that. And so in words in English, we would say if, there's our if statement, two angles and the included side, remember the side that's between the two angles, of one triangle are equal to the corresponding angles and side of another triangle. Then, there's our then part. The triangles, I'm almost out of room, I'm going to squeeze down here, are congruent. So two more. Hopefully if you have any questions, remember if you're in my class, always ask questions. You can do these notes, pause, go back, rewind, whatever you need to do. It's always here for you. And then we have over here now, we have AAS, which stands for angle, angle, side. Remember, order matters. And so I'm going to draw my picture. C, angle A, angle B across is A, B, C. And in this case, I'm looking at this angle, and angle C. I'm going to look at angle A, and